Okay, this is the Cessna problem that came from the 2016 trial. As per usual, especially for more difficult questions, underline the words that key words. Velocity is 30 meters per second, so we know it's a steady climb. We're not accelerating. Makes life easy for us. Constant angle is 10 degrees. And the pilot and plane have a combined mass of 600 kilograms, and the thrust is 1900 newtons, and they're asking what is the lift to drag ratio. Now, I may have given you a little bit of a bum steer on this question, because I was saying that you can't use theta equals thrust minus drag over weight for this question, because theta is not small enough, and that is true. But we derived this formula from another formula, which was tan theta is equal to thrust over weight minus drag over lift. And we can use this formula to solve this problem. And I'm going to show you two methods, but for this one here, all you need to say to yourself is, you could always make your life easier and draw a diagram of the aeroplane and say weight is straight down and it's going to be 6,000 newtons, because we know that our thrust is equal to 1900 newtons for this problem, and our mass is equal to 600 kilograms, and therefore our weight is 600 times 10, which is 6,000 newtons going straight down, because it's always acting straight down if it's a weight force. Our thrust is acting in this direction, and it is 1900 newtons. We have a drag going this way, and lift always acts perpendicular to the climb, and we know that that is 10 degrees, and that's our lift vector there. So we do know a few things. We know our weight, so we've got that value there. Our weight value is fine. We know our thrust. We don't know this drag and lift, but they're actually asking for the lift to drag ratio. So if we can find that value and we inverse it, we've got our answer. So it's actually quite a simple question in that respect. All you need to do is get your calculator in the right mode. That would be a good start. All you need to do is use this equation. So you just go tan of 10 degrees, because we've got that 10 degree figures, is equal to thrust, 1900, over our weight, 6,000, minus d over L. So we're going to find out what dl is. So all we need to do is take this value, solve for this value, and we've got our answer. So all you need to do is say, we need to subtract this value from this side, so we need to subtract it from this side as well. So we're going to say tan of 10 degrees is equal to 0.17, and we're going to subtract our 1900 over 6,000, and we end up with an answer of minus 0.14 approximately, is equal to minus d over L. So if we find the inverse of this, we'll have the lift to drag, which is what the question is asking for. So all you need to do that is, you've got this x to the minus 1 button, which is your inverse button. So if you push that button and hit equals, you end up with 7, okay? And that means that your answer B, which is the correct answer, 7-1. Okay, so that's one method of doing that question, using the equation. But like I said, it might be a very good idea to learn this equation here, tan theta equals thrust over weight minus d over L, and then just remember that for small thetas, that this question for like glide problems where it's very, very small angle, you can use this, and for all other situations you'd want to be using that equation. So that's one method of solving that equation. to get to the correct answer. So you just need to use that equation. Solve for d over L, and because that's drag to lift ratio, when we find the inverse of it, we've got lift to drag. Very, very simple way of doing it. The other way, a little bit more complex, but it's the way I ended up solving it, was you look at your plane, and your plane is flying at 10 degrees, and then you're playing around with all the forces on the plane. So we're going to deal with forces that are up and down the plane and perpendicular to the plane as well. That's how we do it. So we know that we have a weight acting down, which is 6,000 newtons, because we already did that in the last question. We know our thrust is equal to 1900 newtons. We know this is our drag, and this is our lift. So what we're going to do is we're going to say all the sum of the forces this way, plus and minus, are going to be 0, and all the sum of the forces this way are going to be 0 as well. So we're playing with that idea of going with the plane. So we can say that first of all, we're going to be doing sum of forces parallel to the plane. That means up and down the plane. So we're going to say sum of the forces parallel, and I'll say the plane is positive, is going to be equal to 0, because this is a steady climb situation. So we're going to say 0 equals up the plane is positive, so we say 1900 for the thrust, and then we're going to say minus d, but we've actually got a component of weight that is going to be going down this way, because we're dealing with forces that are perpendicular to the plane and up and down the plane. So there's a component of this weight force that's going this way, okay? So we need to work out what that component is, and of course we know from our work with weights on inclined planes that this force acting down is going to be minus mg sine of 10 degrees, mg sine theta. Okay, so now what we do is we're going to take our d over this side here to work out our drag, and we're going to say drag is equal to 1900 minus, we know mg is 6,000, minus 6,000 times sine of 10 degrees, and we end up with 858 newtons. Yay! Okay, so this question is asking for lift to drag ratio. So we've got our drag already. Now we have to work out our lift, which is forces that are perpendicular to our plane. Okay, so we say to ourselves, and I'm just going to do this. Perpendicular is what we're looking for. Sum of forces perpendicular is equal to 0. And so now we're going to say 0 is equal to, up is positive, so it's lift, and then we're going down, and that's minus, and this component here is mg cos theta, which is going to be 6,000, which is mg, times cos of 10 degrees, and therefore L is equal to 6,000 cos 10 degrees. So we go 6,000 times cos 10, we end up with L equals 5908, newtons. Okay, so all I've done there is gone 6,000, I bet you that wasn't on the screen, times cos 10, 5908, and then we're going to go lift to drag. So we just take this lift figure and we put it over this drag figure. So if we go 5908 divided by 858, we get 6.9. Okay, 6.9, which is close enough to 7 to 1. Okay, so once again, two methods. You can either use your tan theta equals thrust over weight minus d over L. I would strongly advocate learning that formula. Stick it in your head and make sure you remember it. And this one for small angles of theta for drag, for glide problems. If you remember those two and then have an understanding of forces on aircraft in flight, you're going to be in good stead for answering that type of question. But like I said, working out forces up and down and perpendicular to the incline of the climb is also a method that works. Hope for that it helps you. If you have any questions, please email me, but definitely have a go at doing that question because it's going to be beneficial in the future.